Sure. Okay, there you go. I think I was able to get this live on YouTube and other places. No, I don't know if I was able to do that. Let me check. If this is on live. Okay, yeah. I'm sorry, everyone. There's a last minute configurations that I had to do for Restream. There was something that broke and I was not able to do that. Yeah, okay, there is a YouTube live stream link too. Let me forward that to you. It should be on our Agent Varsity channel. Let me share that if you want to join on YouTube. And we also have that live going on let me share that link here. There you go. Absolutely. So thanks everyone for joining this our meetup on vLLM. There is a poll for every one of you. Like if you want to go ahead and just fill that poll, it would really help us to gauge the background of everyone who joined this call. Um, so before going through or starting this tutorial, I just want to tell you that we'll be going we'll going through this vLLM tutorial, but this might be a bit more technical if someone is joining for or just getting into learning AI for or maybe Gen AI. So we are mainly talking about how to host these LLMs. So we're not working with APIs here, but it's more of how do we host via LLMs on a GPU. So we have already provided with the pre-work. So if in case you want to follow along, we have a pre-work prerequisites link that I have actually forwarded through Luma. Hopefully most of you have got it. If not, I can share you that link that you can use to follow along. So it starts with um, it starts with uh, creating a GPU. So if you don't have a GPU, local GPU, we at least need 20 GB VRAM or 15 15 to 20 GB VRAM. We're going to work with a 7 billion parameter model. So if not, you could host or provision a DigitalOcean GPU droplet. We have created an article for you to follow along to do that. So it might charge you probably few 80 cents a hour is what I believe it should charge. But yeah, this is let me share you that link that you can use. Just a minute. I'm going to share this here. Okay, there you go. Yeah, so that's a SharePoint link where you can check for the check the steps to create DigitalOcean instance for or droplet for you to follow along. If you don't want to do it right away during this call, you could always do that later. But it does have all the steps on how to install vLLM and all. So let's get without any delay, let's get started um, with the presentation. Uh, since this is more of a community event. So if any one of you already have experience working with vLLM, so if anyone has any questions, please do feel free to drop those questions in your chat. If anyone can answer those questions as well and good. If not, I will always have time for us to discuss, have back and forth questions, or maybe have uh, uh, a I'll have separate time for questions because it's a couple of hours long meeting. So let me go ahead and share this screen. Yeah. Okay. There you go. So for someone who's just joining through Meetup, I know there was a Luma link that you actually have to register. So I'm really sorry about this. It's we are moving all of our meetings to Luma eventually. So that's the reason why I had to put a Luma link. But you would only see the Zoom link once you register. So we did provided that update today. and yesterday about this, the way to get into the meeting. But yeah, let's go ahead and start work. I'll go through some slides on vLLM, and then we'll have a hands-on session. We'll be showing you how we can host a model, Mistral 7 billion parameter model, and also go through some of the metrics that are really important for us when we are hosting a model. So understanding vLLM, hopefully, I'm not sure if anyone have already worked with vLLM. So if you have already done that, please do comment, or please do drop that in the chat section. What have you done with this? We're definitely very interested to know more about that. But what we're going to discuss today would be around. First thing, we're going to talk about transformers and self-attention, because transformers and self-attention are really important for us to understand the problems with hosting in LLM. And we will not go through a lot more details. We'll just go through some high-level concepts, not going to explain any of the math behind it. It's just around giving you some analogies, explain you why we need self-attention. Like what is that you need to understand about self-attention? Because if you don't understand that vLLM's advantages, we can't really grab the value of vLLM. So transformers and self-attention. We'll also go through KV and KV cache. We'll be talking about various stages in vLLM, what are the different LLM serving challenges, what is a vLLM, and then we'll also go through different techniques within vLLM. So let's go through transformers and self-attention just to understand what goes through these LLMs. But I mean, what is an architecture of an LLM or GPT model? So the LLMs, or most of the GPT models, which is generative pre-trained transformers, so these are all built on a neural network architecture called transformers. It was introduced in 2017 with a paper called Attention is All You Need. So it was majorly developed to solve translation problem. So translating English to other languages. So that's the whole purpose of building or developing this, because it was a huge problem then in 2017. But yeah, now we're using it to generate generative for building generative AIs. But it was the main intention for transformers was not actually to generate anything. It was mainly to convert one text to from one language to a different language. So it's mainly designed to process sequences instead of step-by-step in RNNs. I don't want to go too deep into RNNs, but they are also a different kind of neural networks, but they're kind of legacy. And what exactly is attention, right? The human language is a signal that is very it's a signal that we humans talk to each other, but the language itself, the data itself, has a lot of it's really complicated. It's not like when you have a dog or a cat image, you're looking at different patterns within that. AI would able to learn if it is dog or a cat, because it might learn about different patterns in the data. But when you are dealing with natural language, if you look at this example, the cat sat on the mat because it was tired. So when you see it, so what does it refers to, right? The word it here refers to cat. So how do we have our model understand this? How can we train a model grab what it refers to, right? It's a problem that that everyone tried to solve previously, and in our case, with attention, the models are able to know exactly what part of the sentence that it has to pay attention to. That's the word attention, right? How you attend, or what kind of attention that you need to pay within a sentence. And that's what humans do too, right? We as humans, we don't pay much attention to rather we just pay more attention to cat, sat, and mat, because these are the things that we have to really think a lot about to predict what would come next, or even to answer a question. So these are some of the important things that you probably need to grab or grasp when we are trying to answer a question. So attention helps the model capture these dependencies, right? These are huge dependencies. Every word is dependent on every other previous words. So how they are forming, how the sequence flow. So it's very important for us to make uh, you know take those dependencies into picture. So the with attention, we are able to understand the context because the context could be different based on how the previous words are arranged. You could say, I'm going to a bank. So the bank could be a river bank, it could be a financial bank, it could also be a blood bank, right? It all depends on what are the preceding words that, or how it is used in a complete context. Each word has multiple meanings. So that's the reason why by having this attention algorithm, we are able to improve the context understanding, have these models, predict the next word, or even, generate new sentences as well. So it does enable large scale training because of attention. It's self attention. So it's a highly scalable way of training a model because the text itself would be treated as the training data set. So that's really being a huge benefit in terms of scaling up the training examples. You're just using plain text to train the model, and how the training happens. We're not discussing anything about training, but self attention really scaled up the training for these large language models. That's really added a lot of value. And you see even every model that's coming up now, it's all based off transformers. Even though there are some models which are based off Mamba, but they're still way behind transformers. And they're also fast and accurate than older models. So, so what is the few things that we need to really worry about? Like we need to learn what exactly is Q, K, and V. These are some variables. So, and if you're really are interested in learning about math behind it, I would recommend a channel called Three Brown and One Blue. If you really want to go in depth around attention, that too with including math, complicated math, please do watch this video. I have put this video here, and I can also share that video in the chat, or I will even share the slides too. So the YouTube video does show everything with beautiful visualizations. Um, three brown, one blue channel. The author really does great job at visualizing different layers of transformers and how this attention mechanism really works. We are not covering any of the math here, but just want to give you a second example just to show how these things, what value does these three Q, K, and V adds when we're trying to calculate this attention, right? Attention is to know which word is referring to other words in the statement. So if you see this, the sentence so far that we're trying to generate is like cat sat on the, and what is the next word? So these LLMs are actually predicting the next word. So to guess the next word, what we need to focus on is cat and sat on. So these are all different. In the LLM word, we call it tokens. So token could be a word or could be partially, part of a word. So, but for our understanding, you can just treat that to be a word or maybe a couple of words. But since cats are just spaces like mat, we attend and we usually put more emphasis on these words. So the next word could either be it could be mat because that would be a high probable word because of cat and sat. So there are two different words that would add more weightage, or it will just the high probable word out of these two would probably be mat. So how does it happen? Like how is the algorithm, the attention algorithm is able to predict that is by analyzing, by creating dependencies that goes throughout the sentence. First thing is every word that it creates, it got three nodes. So I'm just giving an example, it's an analogy, but usually these are huge matrices that are created. But if you see here, Q is what I need now. It means whenever it has to produce the next word, the Q asks this question, which is query. Q stands for query, a question. It says what I need now. So what word I need now. And it does create K and V values for all of the previous words in the statement. So since it is the cat sat on the, it should be able to create K for the word, and K and value for cat, and even for sat, it has to create K and V. So what's going on is it's just asking who this word is and its information. So what is that word? Is it contributing to anything in the statement? So these are these are huge matrices which are grabbing those dependencies, which are just not they're capturing what value or how much weightage does it add to predicting the next statement, right? So that's the reason why we need this K and V to be really important to answer this question is what I need now, right? In order to predict this specific word, it has to go back and refer to K and V of all different words within that statement to predict the next word. So that's what's going on here. So the model compares Q to all of the Ks, right? Because every K is telling who this word is and what its information. It could be any information. It could be an adjective. It could be talking about an animal. So all of this is something that they grab during the training process because these models are trained on huge amount of data. So we are really not worried about what math is going on under the hood as of now. But in general, this is what's happening with these values in the higher dimensional space, in the latent space. So K and V would actually decide which word matters. So is these values will actually tell that cat and sat on would matter the most, not the, because the would not add anything, or it will not add a lot of weightage to predict this word. These two will add because of these matrices that we've been building up from all the way till here. So the model compares Q to all Ks to decide which word matters, and then it mixes all of the V nodes, means all of the information that every word contributed to using those weights to generate the next word. So K and V are really important. So K and V actually decide on what would be that word, but K and V are dependent on all of the previous words. So imagine if you have a huge statement, maybe you have 20 or 30 different paragraphs, the KV for each and every word in that paragraph would actually predict one word. So it's a huge matrix that you need to solve. So that's the reason why ChatGPT or all of these models are autoregressive. They take up one huge paragraph, and to predict one word, they need to process huge paragraphs and then come and predict one word. So it's just autoregressive in nature. And if you want to understand this in a deeper way, you can always see this video. So if you see here, right, there are a few things that are happening under the hood. So imagine that we have this word, the statement, Paris is the city. So when you're feeding or when this information is sent to these LLMs, first thing what we're trying to do is LLMs doesn't understand words as it is. They understand math, right? We probably need to change, update these words, map them into tokens. So we are just creating different token IDs for all these words, and they are mapped into numbers. And these numbers are later transformed into embeddings. So they're again huge numbers. Like these embeddings could be really long, very big. And then these embeddings would later on be sent into the LLM. And within the LLM, the same process that we previously talked about, the KV calculation happens, and then it will generate the next word. So it's not generating, it's predicting the next word. So it's not predicting one word, rather predicting a lot of them, but it just predicts the one which is of higher probability. If you see off is the high probability here. So it's going to predict off. So because the prediction is high. So this is how we are predicting the next word in an LLM. We are not generating huge sentences at once. Now, if off is predicted, now the next iteration, Paris is the city off, would go into this process again to generate the next word. So that is how you're trying to rely on this, rely on the KV cache to generate, not KV cache, but this is how the LLM generate a single token. But what's going on within an LLM is the huge matrix multiplications of KV cache that's happening within these LLMs, where every time you do Q to find the next token, you get this K and V's of all the previously generated tokens or words need to be calculated and looked at. So that's because that's where all of them, we need to attend to all of those previous past tokens which are generated. So that's really how LLM generates an output. So we call it, technically we call it forward pass. So if you don't, your forward pass is just you're just passing it from, forward from the LLM to the output. In training is when you actually listen forward and backward pass to train an LLM. But when here, as of now, we're not talking anything related to training in this session. We're only talking about inference. So now, since we know KV is a huge deal, because with KV you're able to predict what is the current word. Because when the LLM asks what I need now, it has to go back and refers to all of the KVs. But what happens if in case I generated off, now I go back, I put my off here, now whole statement is getting to the LLM, but do I need to calculate KV again for all of these? Because we already did that, right? So we don't have to, we could do it, but that will again add latencies because every time you're computing this KV again and again. And all we are doing next time is just concatenating a new word. So you just create, KV for off and just use the previous KVs. So we are so that is where KV cache comes into picture. So we are whenever we're reading or writing, right? We are basically going back and referring to all these previous words. So that's what just an example like how we're doing, and we already know the transformers also do the same thing. Like whenever it is writing a next word, it's going back and attending to all of the previous words. So each time a new token is generated, it has to attend to all of the earlier tokens just to maintain the context, right? So instead of calculating attention every time in every step, LLM stores that key and value tensors in a cache so that you don't have to recalibrate every time. And you could just use that cache and generate the next word. So now if I have maybe I sent a huge storybook into my LLM, now I ask it to summarize maybe a 20-page PDF, and now I ask to summarize, that itself creates a huge KV cache, right? So, and in order to generate one output, you need to generate a huge matrix of KV, and that need to be stored in the memory because that is where that is what used to generate one word. So KV cache maintenance or management is a huge problem. And as your input grows, KV cache grows, and as the KV cache grows, the backend where the LLMs are running would require huge memory in the GPU memory. So how do we manage that, right? That's where vLLM comes into picture. So if you understand the basic problem is attention is creating KVs to generate a new token in an autoregressive fashion. We need KVs for all of the previously generated content. And that KV is huge because whenever you ask summarization or even you're asking any question to by giving it a statement, it could just not be summarization, it could be any problem, right? You're asking it to generate probably a 300 or 30, maybe a 3,000 lines of story. So even then, as it generates, every time it has to keep on calculating KV for every new token it generates. So the KV cache keeps on increasing. So how does ChatGPT or any of these LLM providers scale, and how do they address every request that's coming in, right? That is what we're going to learn today. There are different strategies to do that. So there are two stages that you need to understand here. So what is a pre-fill stage and what is the decode stage, right? So we already understood that whenever we ask a question to ChatGPT, imagine the question is a listening stage, right? It could be ChatGPT or any model. It's listening to your question. The question is, it could be a question, it could be a PDF that you're sending, and it has to listen to all of that. So listening in the computation world means you're calculating KVs for all of the question. It could be it could be a few lines question. It could be a huge PDF file which has maybe thousands of hundreds of pages that you're trying to summarize. It has to listen and calculate KV for that. So it keeps on calculating. So it's compute heavy. It's compute bound, and it keeps on have to calculate all of that to create a KV cache, because now to predict or to answer that question, it needs that KV cache. So that is a pre-fill stage. A pre-fill stage is the listening stage, just as an analogy. Now the model has to give you an output. So think about that to be a talking stage, where the model has to talk, but it has to keep in mind every possible input that it got previously to answer that question. So it has to refer to the KV cache, go back, read to KV cache of every word, and now predict the next word, and keep on sending it back into the model to again generate one word at a time, one word at a time. So that's where so the initial listening phase is called pre-fill. So it could be any prompt that you're sending to ChatGPT, and you're just waiting there. So it means that you're waiting there because your model, the ChatGPT, is actually doing pre-fill. And the moment that you see a word, oh, now the model is talking. So that is a decode phase. So the model already generated the KV cache, and now it loaded KV cache into its memory and generating every word step by step. So just keep on generating one word after the other, one word after the other. So what's happening with this is you have prefill, which is compute bound, because you have to do a lot of calculations to find KV cache because there's huge matrix multiplications. And then you have a decode phase where you know this calculated KV cache is in memory, and that you need to use to answer the question. So decode is memory bound. So it does require a lot of memory because now you're storing this KV cache in its memory to answer. So these are the two different phases that you need to remember. And that's where this prefill and decode phase comes into picture. So whenever you're chatting with LLM, so now you know exactly what's going on. So when you give your question, just dump your question into ChatGPT. Now it's a prefill stage that's going on. And now the decode stage happens when once a prefill stage is done. Now next comes the decode stage, where it starts generating the token sequentially in an autoregressive fashion, and then it's memory bound. And what are the metrics that define how well is your prefill is time to first token, right? Because how much time does it take to generate first token? That tells you how much time it took to compute the prefill, how much time it took to compute the KV cache, right? It has to compute Q, K, V vectors. So that gives us this, to create an SLAs, or it probably be you're building your own LLM, and now you need to check for how much time it's taking to generate first token. If it's taking like 5 minutes, then you need more compute, because your GPUs are compute bound, and you probably need to throw in more computation. You probably need to do more compute there. Decode phase is the memory bound phase, and here what matters is the inter-token latency. So I generate one token. Now, how much time it takes to generate a second token? So if you see ChatGPT is generating one token, but the next token generation is so slow, you mean that they are really limited on their memory part in their GPUs now, right? So these are some of the key metrics that define how the performance of your LLM is with the prefill and the decode stage. And this is just an analogy I have done just so that you understand how this works. So there are two things with an LLM, right? LLM training is what no one is concerned about it right now, because training is something that the model providers do. All we are talking now is the inference phase or the serving phase. It means we already have a trained LLM. All we are doing is getting an input into an LLM and giving it an output. So what challenges that would happen, right? So now you got your LLM, and you already know how a single request, when it is going through an LLM, what are the different phases? One is a prefill phase, and there's the decode phase. So what could be an issue? What are the challenges, right? Because now you're not serving one customer. You might have thousands of customers asking different questions. Some might just ask, tell me a joke, or some might ask, summarize this huge PDF. So every request is dynamic, right? Each request to your LLM, you need to predict how big is your LLM, how big is your prompt, and if it's a bigger prompt or a smaller prompt, and that requires a lot of scaling in a way that helps to make the most of GPUs, because if your GPU, because we know that a GPU, it could either go into a compute bound if it is doing a lot of calculations of KV, or it could also be a memory bound if it is probably doing a lot of decoding. And since a lot of requests coming in, let's say if someone sent 100 PDFs to summarize, not all of the, maybe out of 100 requests, one sent 100 PDFs to get to summarize. Other requests could not just wait because someone sent 100 requests, or maybe someone sent like 100-page PDF to summarize. Maybe it should not impact my request, which is just asking for a joke. So how can we make sure that the performance of LLM improves over time and it's also optimized? Common issues being the memory pressure, because KV cache grows as the input grows. So now someone put 100-page PDF, it created a huge KV cache. And as the input grows, KV cache grows. So there's too much memory pressure on my GPUs now. And there's also static batching, because whenever you do, when you send one request, and if other requests are blocked till this request is served, it means you're not making the most of your GPUs. You have huge capacity, but now you're just working on one request, which is huge. Latencies and idle GPUs definitely cost them the money, because when the GPU is idle, it means you are losing money. So how do you take care of this latencies? It means time for first token, because these are some latencies that we already discussed, right? Time to first token. If it's taking more than 5 minutes, it means your performance is low. And or even the throughput, which is end of the day, the inter token latencies. What is the throughput? Cost and scale. If you're supporting many users, it definitely requires a lot of hardware. So there are a bunch of challenges that we probably need to address. So in order to address that, there is vLLM, that it's an open source project. It's from UC Berkeley. It's an open source inference system. It's not a training, it's an inference. Inference is, it's once the model is trained, then comes the input and output that it's providing. So just want to put it out there so that you don't get confused between inference and training. So when, and I think it came out in 2013 or 2023 or 2022. I'm not sure, but it's not recent. Okay, if you think that 2023 is recent, in the AI world, that's like 2 decades away. So so it definitely things change so fast in AI. So you definitely have to keep up with new iterations. There's a lot of new inference engines that are developed and all, but yeah, definitely it could be recent, but in AI world, it's not. So paged attention is also something it's a big it's a huge advantage. It's a great improvement for our attention, because now we know KV cache is huge. As the input grows, the KV cache grows, but how are we going to maintain that? So vLLM provides something called paged attention. So it's basically virtualizing all of the KV cache like an operating system. So when I say operating system, so if any of the systems engineers in this call who might have already worked with virtual memory, you would already probably get a gist of this. So they basically created vLLM by getting inspired by virtual memory that were created in the systems engineering space. It virtualizes the KV cache like an operating system, split into different blocks. So now you have huge KV cache. If you're just if you're just storing this huge KV cache in one GPU, it's just like you're completely blocking that GPU, because now that whole GPU has to work to just address one request, and you're blocking that. So what they do is to divide that KV cache in different blocks, so that if one block is done, the new request, those blocks will again be used for the new request. So that is one of the there's one of the advantage that we have with vLLM. It's a huge feature that can help in managing this KV cache. How it is done, there's a blog recently. I think I'll share that. So it's actually in the end of the slides. We do have the blog. It's from Alexis Gordic. I'm sorry, I might have get his name wrong, but it's a very good blog where he explains all this in detail. But it might take a while for you to read. He did discuss everything in detail. I'll share that blog with you if you really want to go and dig deeper into paged attention. And dynamic batching, right? We already know the issue with static batching. So we're kind of freezing up the GPUs just to address huge prompt, maybe someone sending 100 PDFs. So instead of doing that, we do dynamic batching, where you do continuous batching and smartly you schedule the GPUs so that they're always busy, and also you're reducing the latencies, because now if someone's sending a small request, he should get the reply really fast. He should not be just keep waiting there. So an easy integration, vLLM also provides a way for us to expose the LLMs as an API. So now I have an LLM. If someone wants to programmatically access it, or maybe they want to build an agent, so I could do that out of the box with vLLM. It provides OpenAI compatible API that you can just use as a replacement for Hugging Face or TGI. These are some projects from Hugging Face with minimal code changes. So you can actually use that OpenAI compatible API. OpenAI compatible API is just that whenever you have an LLM, you want that LLM to work just like ChatGPT API. I'm just referring to as ChatGPT API, but ChatGPT is just a product from OpenAI. But we have GPT series models. If you're trying to access it to an API, anyone who has experience with that, you have completions API endpoint. So there's a certain format that it comes with. So you can use that out of the box. You can actually make your LLM just work as any GPT model API out of the box. It's cost efficient as well, because it cuts the cost for 50 to 70%. It's a huge savings that you get with vLLM. So I just want to explain that paged attention a bit with an analogy. So imagine that if you have, without any paged attention, you are basically blocking all of the GPU memory to one request or few requests. So you're just, not making use of all of the GPU memory. And paged attention is where you're not using huge desk, like imagine a huge desk where someone's writing an exam, but rather if you have a smaller desk, smaller chunks that you create, just like pages in a book. So you're just trying to not block all of the GPU memory, rather you're just reusing any blocks which have been served. And when one block is served, then the new request uses those blocks and freeing up the part. So you're basically you're basically reducing or even breaking down your attention matrix into smaller blocks, and you're referring to those blocks when it is needed. And if you're done processing, you can use those blocks for other requests. That way, you're not just blocking GPU, rather you're efficiently making use of it. So it's just an analogy that I've created with Nano Banana. So just excuse all of these typos in here. And scheduling and caching techniques. Yeah, we already discussed about continuous batching. It keeps on. In continuous batching, what happens is the vLLM, it schedules, it treats every request and batch those requests together. So batching is nothing but creating blocks for different, for different requests. So you're not just blocked by one huge request. Like it could be any request. If you see here, it could be a short request, medium, or a large request, which might take different times. When you use this continuous block batching, you have a vLLM scheduler that make use of the GPUs efficiently, so that every request is treated in a similar fashion, so that you get the exact output. And you reduce the latencies. Even if it's a big one or a small request, you are reducing the latency significantly. So that is the advantage with continuous batching. And how does that happen is actually through, if you go and look under the hood, there's a vLLM scheduler, there's a lot of paged attention blocks. So you use them to manage the GPU's resources efficiently. If you want to read more about it, I'll share the blog. You can do that. And there's also chunk to prefill. So if the prefill is really huge, so if there is one huge long prompt, so you actually break that prefill, because we know prefill is more compute intensive. So you can actually split those long prompts into smaller chunks, so that you're not blocking your GPUs to be compute bound, right? Because it does require a lot of compute to calculate the KV cache. So if you have a huge PDF that you're sending with maybe or a lot of images that you're sending, then you probably vLLM does chunked prefill, where it also chunks the prefill mode in which the data itself is chunked, so that the prefill happens in a smaller batches rather than happening at once. Because if it's happening at once, the GPUs are again blocked by compute, and they are just not addressing other requests. Prefix caching is it's nothing but, let's say there could be some words like tell me a joke, or you can say tell me a joke and explain this. So in both prompts, tell me a joke is common. So it does some caching. So it uses some of the KV blocks that are created for tell me a joke, because that way you're making your request more efficient once you cache that. So that way you're sharing that prefix KV cache across different requests. So someone asking, tell me a joke, and someone asking, tell me a joke, and also sing a song, right? The tell me a joke part is common across two different requests. If that KV is already cached, it will probably reuse it across two different requests. So that way you're reducing KV cache calculation for the same request, right? Same prompt. Um, so, so these are some of the techniques. There's also parallelism. So we are not just using one GPU, right? We have hundreds of GPUs. We will probably use hundreds of GPUs. Maybe ChatGPT will probably be using thousands, and a lot of them are also building a lot of data centers because they know the demand for AI would only grow. But how do we parallelize the request? Like, how do we make sure that the AI model is scaled? Let's say ChatGPT has around um, uh, trillions of parameters, but a single GPU VRAM may not fit all of the model. The uh, with data parallelism, so if there are uh, uh, hundreds and thousands of GPUs that are used, and one ChatGPT model, which might be huge, like 250, it might have trillions of parameters, or even if it's billions of parameters. Like today, what we are going to test is 7 billion parameter model, which is very small, which probably require like 15 GB VRAM. So it would fit in one GPU. But imagine if I want to host a 250 billion parameter model, then I have to use multiple GPUs. And how would I do that, right? So a model would have different layers. So you can parallelize the models. Let's say if my model fits within a GPU, as of now, example Mistral 7 billion parameter model, and I have GPUs maybe 4090 that I'm using, then data parallelism is just using models across different GPUs. So you're replicating the same model across different GPUs. So to handle multiple requests. Like now you have many models. So all these models would independently get those requests, and they serve those requests, right? So that is data parallelism. It's just like any application that you are just scaling it horizontally, like you're building more instance of your applications, or you're serving more requests. Same thing is happening with data parallelism, except that here we are scaling up the models. That's called data parallelism. What is pipeline parallelism? So pipeline parallelism is something, a model could have multiple layers, and the data flows between these layers, right? They could be attention blocks, because attention blocks are calculating the KVs. And also there are feed forward networks, which are really dense networks that will actually grab some, they actually, learn some patterns within the data. So, and these are all blocks which are concatenated. So this huge 250 billion parameter model could have these layers. And if you want to host them on the GPUs, you need smaller GPUs, but there are a bunch of them. So you can actually divide the layers of this model across different GPUs. So that way you are basically creating pipeline parallelism. You're splitting the model into different stages across GPUs, and you're having this micro batches that flow between the pipeline sequentially. So basically what happens is now there might be some latencies involved, because now your model is split between different GPUs. So the data has to flow between these different machines. There could be some latencies, but you are basically saving around the memory, because you don't have a huge, you're not blocked by you're not just blocking one huge GPU just by hosting, one big model. I mean, they're not. There's also like, uh, even hardware-wise, it might not be available too, right? Those GPUs. So that's something that's called pipeline parallelism. Tensor parallelism is just when you're calculating, there could be huge tensors that might be created. These tensors are nothing but KV cache, right? In KV cache, K, Q, and V, these could be huge matrices that need to be split across GPUs to do some math. So there's a huge matrix that it has to host, and you're basically breaking down the tensor into different GPUs. When you're doing tensor parallelism, you should understand what is the model, how the model architecture is, how many heads of attention. If you don't understand that, what heads are, you don't have to worry about it. I mean, since I have not covered a lot of model architecture in this presentation, but when you're doing it, tensor parallelism, you should basically understand the model architecture, because when you're breaking down the matrices, not every GPU would accommodate a model which is not suitable. So tensor parallelism is finely designed to, and it can't fit. You can't do this tensor parallelism for every model, right? There should be model architecture should able to be accommodated on those GPUs. So if the GPUs cannot do that, you can't just chop a matrix. You have to chop the matrices evenly. If not, then you can't do tensor parallelism. So you have to be careful when you're doing tensor parallelism. So there are other features too. Speculative decoding is one of them. So speculative decoding is when a small model, it actually proposes maybe 5 or 6 different tokens at once. So we know a model could able to predict one word at a time, but with speculative decoding, you have a smaller model predicting 5 or 10 different tokens at once. And now you have a bigger LLM, a bigger model can just say yes or right or wrong, and then accept those tokens. If there's wrong, then it will change it. But a small draft model would actually propose all of the next 5 or 6 different tokens. So that's what speculative decoding is, and vLLM supports that speculative decoding. So you do that with vLLM. Flash attention is basically an algorithm to increase the speed of your attention. So I don't want to go deeper into the flash attention. It itself would probably be a different presentation that I need to talk to. So that's the reason why I don't want to go deeper into this, but it's just that how well you can optimize your attention so that you get faster results, just to speed up the output. Hardware or API, so that it can run across NVIDIA, OpenAI compatible APIs is obviously we discussed before. Quantization is something that these tensors that we are building or we are working with in matrices, they're huge. They are float 32. So float 32 is like you have huge big numbers when you're trying to multiply or add. So that would probably require a lot of resources to do it. But if you want to work with them, so there is a concept called quantization where you're reducing that float 32 number to probably 4 bits. So what happens with that is your performance would reduce, but one advantage with that is you probably need very significantly low resources. You could even run like the recent GPT models that were open source. You could probably run them on your Mac or even any of your Windows machines because they are quantized models. So they are probably int4 models. The performance would not be equivalent to the float 32, but still you could run them, right? You can even run them on small edge devices. So vLLM supports quantization out of the box. So you could probably use that to do GPT-Q or, int4 or 8 or FP8. These are some things that can help you to shrink your model size so that you can run them. And yes, I mean, vLLM is huge in terms of like you see a lot of benchmarks in running LMSys is basically a benchmark. It cuts the GPU count, so it probably required twice as many GPUs to run that. Now it's reduced. It just requires 2 to 3. It's serving more requests, and it's also cutting down the number of GPUs with vLLM. The inference cost is significantly lower. You could also build real-time chatbot, summarization assistance because of with vLLM. And also it has an active community, and a lot of enterprises already adopted vLLM, and you'll probably see that in multiple across different communities and enterprise environments as well. Um, so what are the major takeaways from this? Memory is important. So paged attention, it's actually treating KV cache like a virtual memory. So that way you are making the most of your GPUs. Continuous batching is making sure that GPUs are always busy, not being blocked by huge requests and all. So that's really helping them to make the most of the compute and the memory that's available in the GPUs, and also significantly reducing the latencies. And there's also a lot of optimizations that vLLM provides out of the box. Quantization we discussed, speculative decoding, a lot of hardware accelerated kernels. That way we can reduce the size of the models, or even speed up the inference process with speculative decoding. Open and compatible, so simple API integration. We can expose an LLM using OpenAI compatible API. That way anyone can consume your LLM just through by following the same process how they would be doing for GPT models, because OpenAI API compatible is something that will follow the same standards as OpenAI. So they made it open source for anyone to adopt. So vLLM provides that out of the box. Real world impact, definitely huge throughput gains, cost savings. I think these are all some of the major advantages. Next, we're going to see the demo. We're going to see how pre-fill is happening, different metrics, all of them for the Mistral 7 billion parameter model. I'll probably have to stop sharing and have someone share the screen. Before that, I think we have 5 more minutes to complete an hour. So if you have any questions, we can discuss those questions. But I want to share this blog with everyone. It's a great blog. I think it does cover vLLM in depth, so you could read. It's fairly technical. So if you have any questions, please always use ChatGPT to understand these concepts in depth. Yeah, so this is where you would understand with diagrams. I think he did a great job in explaining all of these concepts in a easy to understand fashion. But yeah, uh, and giving very simple examples on how the paged attention works, how these different blocks can divide your KV cache, and optimize the inference speed and all of those. So yeah, I'll be sharing this in the chat if you want to look at it. Um, so okay, I do see a lot of discussion that's happening. That's great. Okay, if no one has any questions, okay, I think you're all trying to create the DigitalOcean instance. That's great. Okay. So Daniel asked some questions. How do I estimate the number of users that a single H200 GPU can support? It all depends on how big is your model and what model you're hosting. How do scaling calculations work in multi-GPU environment? My client has one server with 8 NVIDIA GPUs, what are common GPU slicing, serving manner that on-premise AI engineers recommend. So end of the day, it all depends on the model that you're working on, and how do you divide across different GPUs is again, if you want to go with any kind of parallelism, you could go with tensor parallelism, data parallelism, pipeline parallelism, but all these only matter depending on what is your model that you're hosting, right? And what is your latencies, SLAs. But yeah, 8 NVIDIA H200s really sounds great. I mean, you can definitely it definitely has a lot of resources. Which open source models perform well as brains behind AI coding assistants, which using Frontier SaaS? Yes, Qwen 3 Coder is amazing. I mean, if you really want to use Qwen 3 Coder, even the quantized version is doing amazing. So I would recommend using Qwen. Thanks, Samanini, for that. Yeah. So I think, okay, sure. I mean, that's great. I'm seeing some discussions here around parallelism. Uh, Thanks a lot, everyone, for sharing your knowledge here. So let's go ahead and review. I mean, if you don't have any other questions, if anyone has any questions, please feel free to ask. I'll probably address that for the next 2 or 3 minutes we can do, and then we can see the demo. Like if you want to follow along, make sure that you have your DigitalOcean GPU available, and we'll just show how the vLLM is installed and how you can host a Mistral 7 billion parameter model, and also look into some Grafana dashboard on different metrics that we actually care about. Okay. If no one has any questions, then Sai, you could go ahead and share your screen so that we could go ahead and review how uh,
Yeah, sure.
vLLM works. Yeah, thank you.
So first, someone like you need to create a DigitalOcean go to dashboard, go to DigitalOcean dashboard and create a droplet and choose uh, this OS like Ubuntu 22.04. So have this GPU type RTX 4000 that has 20 GB VRAM, and please SSH to it, and yeah, install NVIDIA drivers again next, and you need to install a Python virtual environment here. So again, we need to install the dependencies like vLLM transformers and Hugging Face. So coming to the Hugging Face, you need to have an Hugging Face account, and you need to create an access token for that. So it starts with HF. Uh, I'll just walk through this, and yeah, so you need to log in here using this Hugging Face CLI login, and so these are the models if you want to download this, like here is the example of small VLM, and this is the Mistral model. So after installing all the dependencies here, so we need to run this vLLM serve command, and we need to pass using curl command, what is the content, write a short summary about the importance of the regular exercise. So this will be the
Sai,
output.
I'm sorry for interrupting. Can you go ahead and show this, how we are doing all this practically,
Yeah,
like in the model? Yeah, thank you.
yeah. So I'm just running the Mistral vLLM serve command.
So this should be straightforward for anyone to run. We didn't face any issues while running it. All those commands that are there in the document should be fairly straightforward. If you ever have any issues running it, please do reach out to us on the Meetup group. We can help you out with any questions that you have. And we have already pre-installed the vLLM here. As of now, we are running this model. If you see here, it's able to capture all the CUDA graphs. CUDA graphs are something that make it's more efficient to create this initialization as a graph, so that it's one of the optimizations that happens in the CUDA level, so that you don't have to redo all of this initialization, how the model loading is happening. All of them is it's more of a DAG that it creates, so that it just repeats it next time when you're trying to run it. That way, you're saving the model start time, and all of those. So looks like the model is up and running. And as of now,
So this
Sai
is the
is able
curl
to,
command.
yeah, he's able to just execute that with a curl. He's just asking Mistral model, write a short summary about the importance of regular exercise, and let's see what it answers.
So this is the response of the model.
So you get the response of the model as of now. So is it possible for you to share the Grafana so that we can see?
Yeah.
So we have this Grafana dashboard where you can actually see how the throughput is there, or even you could look at time per output token latencies, end-to-end request latencies, um, and how these time to first token latency, because time to first token latency is really important because that is the prefill stage where the KV cache has been created. So you could look at that here, right here, how much time it is taking for us to get the token output token. So if the time for first latency is increasing, it means the KV cache creation is increasing and your GPUs are compute bound. It's taking more time to compute it. Um, and you could also see request generation length, how much time it is taking to generate it. Request prompt length, which is just checking how big is the prompt. So these are really important for analyzing the GPU performance given a request. Someone is sending requests, then these metrics really play a huge role in seeing how your system is performing. Um, and if you go down and see, there's also a queue time that you can visualize. Um, Come down. There's a request prefill and decode time, how much time that is taking to prefill and how much time taking to decode. So you could probably look into those aspects as well here. Um, yeah,
Like this is the continuous batching script as well. Like we are concurrently running these prompts in
Yes. So
continuous batch.
now, so the reason why we have done this is continuous batching is like now we are sending the script to for different prompts. So we are sending like 4 different prompts to check if what would be the time to return all of it. Because if we are sending it sequentially, that would be a blocking way of asking questions. But with continuous batching, you could actually get the response really fast because with continuous batching, you're not waiting for one prompt to be finished or one decode stage to be finished. Rather, you're just doing that in a continuous fashion. So yeah, once this is run, you could see the output for these prompts, and you can also check the GPU utilization here on how this different requests happen. What is the latency for all these requests, and also how are we able to use our GPU KV cache? The KV cache is something that we can visualize and check for with continuous batching or without continuous batching, what would be the overall latencies. So with continuous batching, we were able to get the response really faster. Rather, if you're doing that in an individual step in a sequential way, it might take a while to get the response. Um, can you refresh it? I don't think. Can you refresh it again, Sai? Thank you. Yeah, I think keep refreshing it. Might be taking a while to get those metrics. Yeah.
So like yeah, these are the latest metrics. It is on 8:07 p.m. Yeah.
Sure. Thank you. So you could see this Mistral 7 billion parameter model can um, Sorry, I'm just trying to get this PDF, the presentation, the PPT. Good. Copy links to the okay. There you go. I'm just sharing that here. I could rename it, but I'm not able to rename it. One of my team members has edited this slides, and I'm not able to rename this. Can a single vLLM instance serve multiple AI models? You could, but the best practice is to have multiple instances of vLLM to serve multiple AI models, Daniel. You could do that. You could actually host different models within one single vLLM, but okay, yeah, like Olama does, yeah, that's fine. You could do that, but Olama is meant for not production. It's actually meant for local. And the reason why we have separate instance of vLLM is, every model is different. Every model architecture would be different. So if you have one single vLLM to serve this model, then uh, you might override the one configuration. You're only limiting to one configuration for all of your models that you're serving, right? So having a separate instance of vLLM for different models is the best practice. Yeah, sounds good. Thank you, Sai, for showcasing the demo. I mean, if you want to go through this step by step, you could start doing that. Oh, yes, Ashwin, I can share that to you here. I think I already shared that in the beginning of the presentation, but let me do it again. Uh, so this will be the SharePoint where you can review the step by step process to uh, to work with this tutorial. So if you all want to, I mean, you can try it right now, right away. But only thing that might take time is the DigitalOcean account creation. So if you have that ready, you can just start using it. Start working on this. If you have a GPU locally, you could still use that as well. Unfortunately, vLLM doesn't work on Mac because even though Mac has GPUs, vLLM use paged attention, and paged attention algorithm, the kernel is not supported by Metal by MLX, and that's the reason why I think we cannot even. That's the reason why we cannot run vLLM on Mac. Uh, you could host a model, but not using vLLM. So you need a Linux machine to make your lives easy. So yeah, so we also have a Agentversity bot in this meeting. I mean, if you has any questions, you could ask it. The reason why we created it's an experiment that we're doing. Soon we might have this Agentversity bot come join these meetings through audio and even video so that it can listen to us and even answer questions. So we're just working on it as of now. I mean, it took us just a couple of days to build this bot, but later on, we are trying to use Agentversity as a bot that can be part of our uh, cohort and help with questions, planning, training, planning, even any of the future tasks that we're going to do. So I think we will have Agentversity bot ready pretty soon. So I just want to give you a brief about Agentversity and what we do. So a we're building a learning platform that allows a human mentors and AI together help someone upskill themselves into being an AI engineer. So we are building. So the problem now with most of the bootcamps is they are one size fits everyone, but we are trying to get hyper personalization to everyone so that they could define their own career goals, and we try to build the path for them dynamically. So they could be a backbone course, but they still would get some projects. These projects are not just capstone projects, but these could probably be a production ready micro MVP apps that you can, if needed, you could actually start your own product with it. So that's one of the goals for us, and that's where we are heading towards. Agent Varsity is a community with 22,000 members so far, and we are trying to build, trying to create these tutorials for everyone, for anyone to just join and learn and understand, all of the important concepts in AI. So we will pretty soon release some of our cohort information. It might start maybe in November or even later this year, or maybe Q1. We don't have a concrete date because we're working on some infrastructure on our end, including labs and also some agents that will partner with us to help someone upscale. Building AI agents for training is not as simple as building a stateless AI agent. It's basically AI agent which has long horizon task. It does require a lot of testing, so we're working on those as well. So if you have any questions, please reach out to us. But yeah, we'll be on this call just so that uh, you all have this. Okay, I have a question here. Last question, I promise. No, you could ask questions, Daniel. I mean, when to choose TensorRT LLM over vLLM? So you could use vLLM. vLLM has, uh, uh, I mean, honestly, I'm not, vLLM could be used in production. And I'm not sure when both could be used, but let's ask Agent Varsity Bot this question. Because I'm honestly not sure about what TensorRT LLM. I mean, I know TensorRT is from NVIDIA, but let's see what it would answer. Okay. So it says vLLM when you need flexibility, broad model support, strong Hugging Face integration. When you want maximum performance, lowest latency is a full optimization for NVIDIA. Okay, it's basically for NVIDIA stack because TensorRT LLM is from them. For basically A100s, H100s, and them, especially if you're invested in NVIDIA software stack. So if you're using NVIDIA software stack, then TensorRT LLM is best. And vLLM, because it does have Hugging Face integration, yeah, that explains why you could get so many models from Hugging Face and host them on vLLM. So and choose vLLM if you're cloud agnostic, open source deployment across various hardware. That's great. But okay, looks like TensorRT would probably end up with NVIDIA. Like you would have a vendor lock-in because NVIDIA's GPUs are having great support for TensorRT. I mean, most of them use NVIDIA videos because most of the kernels are from NVIDIA, and you could go with NVIDIA stack if you're using Triton or other kernels, or NVIDIA hardware. So anything NVIDIA that you want to do and you're tightly coupled with them, then TensorRT LLM is best thing that you can use, and vLLM for anyone, even with uh, uh, any open source deployments and cloud agnostic, you can go with vLLM because vLLM has it can be run it can be we can run vLLM on Kubernetes. So wherever you're running Kubernetes, you can have vLLM running there. So I think yeah, this is one of the reasoning that AI provided. Can we serve large models using vLLM on WSL? No way. I mean, WSL is, I mean, I assume WSL is what you have on Windows, Windows system for Linux, I guess. If you cannot serve large language models using vLLM on WSL, first thing is, what is WSL? I mean, is it, I mean, probably, is that what you're referring to WSL as?
But that's a Windows subsystem on Linux.
For Linux. Yeah, on Linux, right? Yeah.
It's really slow. It's really slow, but he can try it if he wants.
You can try, yeah, because it's also Linux flavor. You can try, but oh god, I mean, Windows doesn't even run my VS Code properly. I don't know. I don't know if it can run the large language model, but yeah, you could try. Maybe a quantized one would probably run. Maybe you can use a int4 model, maybe a small model like a Mistral int4 to run on that. But you could just refer to that as small language model, but not a large language model. Yes, definitely. The WSL does have real Linux kernel, but I don't know how big is your Windows. I mean, if it already has if you have integration with your GPU, then you can serve. But I don't know if you have that GPUs available on that.
Yes, I mean, I do have GPUs, but when I was trying to set up vLLM and CUDA on the WSL today, I was running into space issues and several driver
Yes,
related issues, so I was kind of stuck.
yes. I definitely understand that because that's a problem, right? It it's better to use Linux machine, and I also want to know exactly what GPUs you have. Check for all of the metrics. Mainly check for available VRAM, and then calculate that. You can use ChatGPT to check it. So they're saying Linux is required, Windows is not natively supported. Use WSL for Windows. Okay, Python version. But GPU acceleration, okay, NVIDIA GPUs are there. It requires RTX 20 series, AMD GPUs, Intel. So yeah, it's great. It's just providing all of this information here. I think we should improve upon these summary tables. Sai, I think, or something, I think we should probably do a better job here. Summary tables are not that great. Yeah. Okay. Yeah, that's good. Thanks, Brian, for sharing that. I think that might help you to enable NVIDIA CUDA drivers in WSL. If you have Docker, probably, yeah, you can also use NVIDIA Docker to do that. So Chuba, I think we are actually live on YouTube now, so you could check YouTube live. I can share you the YouTube link. And also, I think we might be live on LinkedIn too. I'm not sure. Let me share you the YouTube link.
I've shared it.
I'm sorry.
I've shared it.
Oh, you shared it? Okay, sounds good. Sounds good. Thank you.
They're asking for slides.
Yeah, slides is already done. I think I've already included that in the chat. Let me reshare the slides again. Yes. Sounds good. So any questions from anyone or anything that you want to discuss, anything that you have done that you want to share, feel free to do that. We are community. First thing, we are a community to start with. So anyone who wants to just go ahead and talk about what you have what you have been working on in the AI space, and anything that you want to share, anything exciting that you want to share, please do share.
So so those are not slides actually. It's a documentation
Oh,
of
I'm sorry. The slides too. I think I shared the slides too.
PPT slides.
Yes, let me share the slides as well.
They're
I think there should
protected.
be.
We couldn't access them.
Oh, you cannot. Okay.
But that's okay.
Yes, I mean, I can share the slides again because the problem is someone actually created this, and they are the owners. It's just my someone who does some. He's a designer, and probably he shared it to me. But I'll probably share that in the group, in our meetup group. Yeah,
This is good.
sounds great, Daniel.
Mhm.
So what are you working on, Daniel? I do see you are a founder of Solus Toronto.
I was above the hood guy. So you repelled me from wanting to go under the hood. So I like to use stuff to drive the car. I don't want to know how they're made, but I'll have to.
Okay, sounds great.
So AI engineer, but not on premise. Like I left on premise a while back. Need to convince myself to go under the hood again.
Okay, sounds great. Sounds great. Do you follow a Agentex Foundation meetup events?
No,
Daniel?
no,
Agentex Foundation? No, Ruben. You don't know Ruben? Yeah.
Yeah.
Ruben Cohen, right?
He's pushing Claude Flow too much. Like it can be simplified. Like I looked at the repos, there is so many files there. I follow every consulting, every media. They have simpler framework. They call it compound engineering. So basically, the easiest way for people who are new on the call is just use Claude Code, a command line AI, and talk to it. You get your agents in there. You get the wisdom and the code written for you. And it scales. You don't have to worry about the backend. Anthropic just does the work. So.
Yes. Today I heard that Anthropic is the coding agents were actually doing let me share their meetup group, Agentix one, right? Yeah, it just I don't know, you could just check their Agentix Foundation group and
But it's I don't know, it's too busy. I like simplicity, less is more.
Yes.
So I open the repo, I see many commands, like why do I need a manual? It has to be self-explained. So similar here, it was almost like a turn-off. Why do I need to know about all the parameters? I just want to use it. Push the gas and drive the car. Go places. I don't want to repair it.
Yes, absolutely. Yeah, I've been following Rohan for a while. I mean, I really like his posts where he shares his insights on different things. I think I took his consulting services previously, like just to talk to him about Agent Swarm or something like last year.
I know. He's real good with buzzwords. Yeah, good marketing, good buzzwords, but things can be simpler. So go to every.to. There is nothing as simple as their system. Like it's just couple custom commands for Cloud Code, and it's just a magic. You look like superhero monitoring AI. Nothing to learn, no obstacles. So I'm avoiding hard stuff.
Okay, sounds good. So anyone already working with building agents or anything like that previously? Anyone has any experience or working in enterprise as of now building agents in this call?
Yeah.
Hi guys.
Hey Shanta.
I'm Shanta. I've been building agents for almost 1 year now. I was the founding software engineer with one of a pharmaceutical startup in Boston. Post-Throws AI, we were building an AI-powered CRM in the pharma industry. That's a $5 billion industry. We were trying to take on Viva Systems, but we burnt a bunch of money and that didn't go well. And then now I've switched to I work with Chevy NASCAR team as one of the AI founding AI engineers. And right now I'm building AI agents or like assistants to kind of tell how the driver could do better, or how he could take a corner and such. So I primarily build AI agents for work and AI engineering. So I'm very happy to be part of this. Is my first call with you, Raj, and I think it's great. I did not know about vLLM and such. It was very informative. Thanks for this call, and I'd love to see more of this. Thank you. I'm happy to
Oh,
contribute in any way you want. If you want some help in terms of AI or anything, I have a little bit of knowledge there. Probably I can help you as well.
sure, sounds great. Yeah, Shanta. I mean that's great. You're local to Charlotte. That's nice.
Yeah, I'm from
Are you
Charlotte.
working? Are you in Charlotte? Okay, that's good.
Yeah, I'm in
And
Concord.
you said you work for NASCAR as of now
Kind,
to know
yeah, yeah.
the
Chevy.
okay, Chevy NASCAR, right? So when you say that you are using these agents to improve the driver performance, are you trying to use any kind of multimodal agents, like you're trying to process any videos or images, or just plainly you're converting that to text?
No, not video. Like all the cars have data, like how they
Oh, the
enter
stream
lateral.
data.
Yeah,
Hmm.
I did try video, but video is I don't think I can develop as a single. There's a bunch of founding engineers, but I
Hmm.
believe OpenAI is going to come up with vision, if I'm not wrong, in the next 5 or 6 months, and they're going to annotate video. So I'm betting on them to release the vision, and I believe Turing is I think this is good information for everybody. I believe Turing is the company that's annotating the video data for OpenAI right now. So once they release those video models, probably I might just hook that in for my use case.
So we do work on some projects with video. We I think natively there's only one model that takes in video as an input. The Quen models do that. Even
Sorry,
OpenAI, Quen,
Gwen.
yeah,
Interesting.
Quen models, yeah, Quen models do that. They Quen Real, they take video as an input, directly as an input. I mean, yeah, definitely they kind of learn the sampling and all of that, but the processing is really fast. The
Mm-hmm.
Quen Omni is a recent model that came out like a week ago, Quen Omni 3.
Gwen
It takes
Omni.
video, yeah, it takes video, images, audio, text, all modalities without, and even like doing great with all benchmarks.
Damn.
I know it's not a American model, but still, I think something coming from Alibaba and they made it open source. I think and they also share everything, all of the projects, how they build in research. I think that's amazing to read through the research papers, how they're able to do that. They come up with different algorithms and all.
That's
Um, yeah,
that's
but most of the current models are just taking image input, but you do the sampling. Like you take the video, but it just takes the sampling of it.
right.
ChatGPT video isn't that great. I mean, today morning I was doing a demo. I started with ChatGPT video. It's very delayed latencies, like because chopping the frames, right? So it cannot
Yeah, for
sometimes
sure.
cannot, yeah, it cannot take the input really well.
For
But
sure.
yeah, good to know. So you basically analyze the telemetry data, or you're still talking about once they are in the car, you get the data from the drivers in the sense that you get the
No,
sensor data, or is it? Mhm.
so there's a bunch of sensors data, but then
Oh,
there's a lot to context. Obviously, it's how the drivers would feel. What's the data? It's not just the car moving fast. Is he not sick? Did he break up with his girlfriend? Like there's multiple. What's the context of him not performing well, or what's the context of him performing well? How can we improve that from race to race, and how can we make the driver a champion? So I would connect to Slack, his emails, his day-to-day activities, his driver data, and then see what can be done better. That's my plan for them. Yeah.
oh, but I mean, I don't want to be the driver. There's so much of information that's going out, right? Yeah, I
Yeah.
mean, you guys are just almost like spying on me. But yeah, no problem. I mean,
Yeah.
that might be
Yeah.
needed. Um, Daniel, yeah, thanks for sharing that, Daniel. And thank you, Shanta, for sharing this. Maybe we can discuss a bit more, maybe tomorrow, if you want to share something about any project that you want to share, maybe an open source project that you're building. Yeah, feel free to drop me a message. I can always have an event that, you know, Agent Virtually is supposed to be a community where you share your knowledge. And that way, we can have the synergy. That's really important, right?
For sure, for sure. If there's any, I mean, I came across, I believe this a bunch of people. Open Manas is another framework. I think that
Yes.
the AI community can, no, people use Manas AI, but Open Manas is their local version. You can locally bring it into your company if you don't want your data to go out. And then Open Manas, I believe it's the best web scraper. And then you can there's multi-step prompt engineering that's done as well. So you can put a next prompt, next prompt, next prompt as it's crawling through the web. So if you guys are doing web scraping, uh, use Open Manas. That can be my advice probably.
Yeah. Yeah, that's good. Open Manos is amazing. I mean, you can use computer use and all of this, right? With Open Manos.
But
Yeah, I think
guys,
we should probably do that.
why are you making it hard? Like there are already like mainstream models, frontier models. Why host anything? Like when you can just drive the car, like to use that metaphor. Like there is lots of newbies learning AI. They don't have to learn under the hood stuff to become good at AI and help their businesses.
Um, yes, for sure. But the problem is, right, there are, so every model, the foundational models, by the way, like um, if the foundational models could be a good starting point for a lot of these enterprises now. I see this adoption where they want a bigger model that can give them a lot of data to start with, but eventually they want to have a small language model that they can use internally that can be almost meeting the same performance as a large language model. But now they're not sending their data back into the cloud. Rather, they just have it hosted in their own environment, or it could be AWS that's hosting that
But
small
that's
language model.
misconception.
Sorry.
I believe that's misconception because when you say
Okay.
cloud, like cloud has been like 15 years out there. Amazon Cloud, Google Cloud, Azure Cloud, like it's your tenant. It's extension of your system. Like you have financial systems in there. Why are we suddenly afraid to do it? Like it's excuse to go back retro on-prem. We left on-prem in 2005. Now we're coming back
Yes.
because we're afraid of our data. And we give all our financial records to Amazons and Googles of the world and Azure's. Like
Yes.
it's not a good reason, really.
Yes. That's nice. That's definitely, I mean, whatever you're saying definitely makes sense because we already have cloud. So they're already having the data and the AI, depending on the use case, right? AI might have some latent, I mean, it's not with everyone. Like if you really want to get started without any issue, you could just do that by, calling an API and you get the data, you get the output, you run your evals, it could be agentic or whatnot, and get going with it. I think majority of the time that's okay, but maybe a few clients that might have a use case where they just want to have something of their own, or maybe someone want to just reduce costs overall. Maybe they build a startup, they're really doing great with OpenAI and other cloud providers, and now they just want to reduce the cost. Maybe a startup want to reduce the cost drastically, and they could do that by going with a small language model. I mean, I think that's what OpenAI is doing now, right? OpenAI doesn't tell us what model that they're using. They just say, "Hey,
Yes.
we decide which model, we decide your question, and we decide the model." And they're
Yeah.
just creating an abstraction, and who knows, they're using a small language model and saving a lot of
Yes.
money, isn't it? So I think that's something even startups could do going forward. And with reinforcement learning, I feel like you only need few examples for your model to get really better really fast. We're trying to do an event using Ruler or ART, A-R-T. I don't know if anyone have heard that. It's called
No.
ART from OpenPipe. So
Oh
it's an
yeah.
open source framework. It's an open source framework that I feel like maybe I haven't experimented with it, but I mean I'm aware of GRPO and all of that, but I think it might help in creating agents and without prompt engineer. I mean, yeah, iterative prompting is great, but prompts are still not it can only respect maybe 95% of the time you could get things going with probably having the best prompt out there. But with RL, you're inherently making the model better or the agentic system better at doing a specific task. With GRPO, I think DeepSeek is doing great with that. DeepSeek has definitely done that. Having GRPO can first of all with PPO, you don't have to have a critic network in gRPO, and it's highly scalable way. And only with few examples, you can get your system even do math, right? That's something which I think would be it has a huge potential going forward. So I don't see everyone needs huge models. I mean, small models is good, but it's not for everyone. I mean, you don't have to invest now to get someone to do a small language model, but maybe after your agent is doing amazing, and now you know your OpenAI bill is going really high, or cloud billing is going really high, and now you want to reduce that, then small language model could be the best, just like how OpenAI is doing. But yeah, it's my view. I mean, everyone, yeah.
I'm just thinking, like, you have a business problem, you solve it in the cloud using SaaS models, frontier models, and then you have fears, you want it cheaper, then you optimize, because there is so many newbies here. They're going to start learning how to set up containers, vectors. They're wasting their life when they can be already producing results using what's out there in the cloud, not just kind of OpenAI. I understand people are afraid to give data to OpenAI. But you go through Azure, they guarantee that your data is not shared. You go through Amazon, you got to go from Google. It's your data, it's not in the cloud, it's your extension of your data center in the cloud. So lots of people are looking at it a wrong way. Now I have to do it because we have to optimize stuff, or there is a source code they couldn't share on internet. But really, like, it's just learn to drive the car. Then, if you're interested, go under the hood and try to fix it. We are teaching people to build the car so they can drive, and that's not needed. That's like, but I'm serverless kind of. I always ignore Kubernetes until I had to learn it, because with serverless I could get the same result and run circles around guys setting up the cluster. Because business care about the result, not about us having fun to pimp the car. So I'm just trying to help those newbies on the call.
That's nice. That's nice. Yeah, I mean, definitely it makes sense. Yeah, I mean, we don't have to worry about. I mean, this call is not for. I mean, we're not for someone who won't really build a SaaS product. Just don't worry about vLLM or even Kubernetes. Just go out there. You have your APIs. Just start building. I mean, you don't have to go and learn all of this under the hood. It's just for someone. I mean, I should have put that in the beginning of the call. That's the reason why I said, hey, it's just a bit more technical, that need to understand attention and all. But if you really want to scale or build something in production, you could use vLLM, but not everyone would do that. Not everyone would do that. And also, I see, Danny, I also see, like, with SaaS, I feel like, with coding agents and all.
Yes.
A lot of SaaS would have a lot of I mean, everyone could build their own SaaS, like, Salesforce, maybe they can build their own Salesforce using coding agents. Like, now you have Claude doing it. Now you could build Salesforce, like, probably next 2-3 days. So the SaaS model, I think it will be a place where you have better AI, and now you build your own SaaS. But next generation of AI models would probably live in the edge. They probably live on your phone, probably live in your refrigerator. Yes. So that's where because now maybe I don't want to upload my pictures, my personal pictures to some cloud provider to do a lot of this inference on those images. Like, some people even upload that to check their skin tan, to see how long you can stand in sun to just see the tan level. So, and also one more thing is, like, some HIPAA is also something really important. Like, someone who has disabilities, or they want to share some things, or someone has mental health issues, they don't want to share even. I mean, as of now, there are agents doing that, but with Edge, I think the next wave of applications will be built on Edge, is what I feel like. I don't know if anyone is already working on it. Please do share. But SaaS, in the agent world, SaaS with agentic, I'd say that definitely would have a lot of demand, because building agents is way different than building a static application. SaaS is more of CRUD, but building an agent would require evals, different data set, and it's a whole different set of problems you're trying to solve now, right? Software engineers are going and now solving a co-pilot for an attorney, or maybe a co-pilot for a doctor, co-pilot for different professions, which software engineers would never even dreamt of solving these problems, but then now they're capable of doing it. Maybe they don't have domain expertise, but they can partner with a domain expert to solve these problems. So,
and that's where newbies on this call should start. So if they're new, I see questions, how do I learn it? You don't. You just use it. And then, like, if you watch the announcement, Sonnet 4.5 was announced yesterday. It's not a model, it's an agent inside. It's completely aware of the environment. So you just use stuff and dance with it, and the prompt is your property or your knowledge or know-how.
Absolutely. So is it Cloud 4.5? It's actually an agent that's coming up? Okay.
It's agentic behavior, like it's built in, it's aware of the environment. And so what happens like for building these models, yes, it was used. I personally think that Claude is hiding really smart general purpose agent in the tool that's marketed for AI development, for software development. You can do anything with it. And I think today or yesterday, they renamed that Claude Code SDK to Agentic SDK, because like it's like reversing the sweater. You can you can expose that knowledge as SDK and just build a front end, and that's it. So no need for Kubernetes, for clusters, for all these parameters, unless you have to.
Yeah, I think that's a great thing. I didn't knew that. I mean, thanks for sharing. So, I mean, we started off probably in 2023 doing all this, and I was training with agents, simple agents. I thought, okay, agents would be something that everyone would be building, but now this behavior is also getting baked into the models going forward. That you probably not even needed to build any agents. And even agents are really getting complicated. You want to solve a simple problem, and everyone wants to build agents for simple problems. But it could probably be a simple LLM call going forward, right?
You have to use the MCPs. You have to give it some kind of ways to access your proprietary data. But it is the one deciding when to call it or not. You just use Claude Code. There is nothing else you need to get business solutions quickly. Then you optimize. Go cheaper, go Chinese, go on-prem, go edge. But start running.
Yes.
Not you, I mean the people asking how do I start.
Yes. I mean, absolutely. I mean, Teron, right? I'm actually replying, but it's a great insight that you're giving, Daniel. I mean, whoever in the call who want to start working, I mean, definitely it's a great insights that Daniel is sharing, because if you really want to go out and build something, just start building right away. I mean, you already have a lot of tools out there that you can leverage and start working with it. And even for agentic, as I said, there are a lot of agentic frameworks out there, but everything does the same thing. A lot of even OpenAI says, hey, you don't have to build a complicated agentic framework, not work with complicated agentic framework like LangGraph. They say, you can just have a simple, your AI is smart enough to know what to use, when to use. And with MCPs are amazing. I don't know if anyone in this call knows about MCPs, but they are really great. They are tools that are meant for building agents. The plumbing to interact to do a tool does take a lot of time, but now these MCPs are an abstraction layer that you can just go and talk with anything with simple code. Like you just add a few lines of code and that's it. Now you can talk to GitHub or you can talk to any tool. So definitely a great insight.
And somebody asked where to learn. Personally, I use Anthropic as my 10 commandments. Every article is goldmine. People just don't see that. So there is a Google best practices for agents, best practices for this. They made MCP protocol. So it's start simple and then complicate if needed.
Yes, absolutely. I mean, I really love the Claude blogs. The blogs are really, really amazing. They try to put everything in there. And their research is good. I mean, the MCP, when they came out last October is when that MCPs were released. But I think people started like adopting it a lot, like from February, March. That is when everyone started using it. But yeah, it's really great thing to learn now. MCPs are amazing. I don't know if anyone uses them in production. Daniel, do you use that anywhere in any of your production environment, MCPs?
Yes, we wouldn't be able to work without that. Because so what happens, LLMs are trained certain date, and then you use MCPs to access your data. First one I use is memory MCP. So if you're, because it knows my style. So when I'm crossing environments, it knows how I write, how I think. And so the only problem is you have to keep the shared file on Dropbox, for instance. So that's a simple one for personal use. And then for clients, we're using MCPs for large code understanding. So because I'm helping developers code more effectively, but in big enterprises, there are many repositories and they don't necessarily developers from one or the other. So enterprise best practices are hidden across them. So if you index them all, good AI will surface best practices patterns, then MCP for talking to, what is this, Confluence, Jira, like that's your corporate knowledge as well. So that's a must. So just a smart AI and couple MCPs, and Bob's your uncle.
Yes, yes. Can you share those names of those MCPs that you just discussed about in the chat so that I just want to review them?
Depending on the use case. So I'll give you one. Context 7 MCP.
Yes,
Context
yes, I know. Yes,
is a must because I start every of my prompts with use context 7 to get the latest APIs. Like when you are working on something new, technology is changing so quickly, so you have 80% probability or higher that you're gonna code against the old API. So if your prompt,
absolutely.
and I'm talking Claude code, your Claude code has a starter file, claude.md, or in the competitors, it's agent.md. The first instruction is, fetch the latest API using context 7 MCP. That's the must I have. And then depending on the project, but there are other guys, like you just go to YouTube, top 5 MCPs, they'll tell you. Context 7 is lowest common denominator for developers.
Yes,
For
absolutely.
personal projects, it's memory MCP, but I use the old version, Anthropic, when they announced it. So memory MCP is a good one to play with, and it remembers your style and people you're with, so it's kind of graph. And so every project has it. Like if I'm working with databases, there is MCP for database. You don't need a dashboard. You just tell it, what do you see in my data? So any database, really. Google has good MCPs for databases. But everybody has them, like Amazon has. Wherever you are, vendors are writing MCPs. So
yes, absolutely.
do not install too many of them because they're going to eat up your context. Choose the one you like. If there is multiple MCPs that do similar thing, it's confusing for MCPs. So there is, and since you're asking me, I go to the playlist from Serverless Toronto. Like every meetup is related to real AI, not engineering problems. So recently it's AI, but we are in business 7.5 years. It was serverless, then data engineering, then cloud. So now AI. So serverlesstoronto.org is the meetup. If you want to see what I do.
Absolutely. Yeah, I'll probably do that. Just share that meetup group in that. I'll probably
Okay, I'm
get
looking for
enrolled in that.
Anthropic. That's more important than me.
Yes, sure. So yeah, context 7, I do agree. It's definitely a great MCP that even we use that mainly to get latest documentation and latest APIs. So definitely, if someone is doing white coding, you don't have to end up with some old APIs and things really break a lot. So always try to use MCP. I mean, always try to get latest documentation or different library documentation. So yeah, thank you for that insights, Daniel. I think it should be a great thing. Okay. Oh, cloud core best practices. Sounds great.
But it's not just that. They have way more good documents. So they don't advertise themselves. They don't brag. It's those what is the name of the group? Agentic group. They created a wrapper on top of it, and then they market it better. But you don't need to learn the wrappers in order to use Anthropic.
Yes, I do agree. So I heard this can actually code 30 hours. Is it the same? The Sonnet 4.5 is what it's doing, like 30 hours of coding?
Sorry, I couldn't hear you.
Oh no, I'm just saying. I just read something on Reddit that it does 30 hours of coding. You could just
They
check
brag
that.
about that. Like I don't know. If it goes over 30 minutes for me, I probably doing something wrong. Normally, so if you so I don't know if you're developers, what you do. Like everybody has different needs, but as a software developer, it's literally good old software development life cycle when you had to plan what you're going to do, get the user requirements first, plan the task, architect, and then validate. So everything we've been doing last 20 years is suddenly possible because you have AI to do the work for you. So
yes, absolutely. I do agree with that. So when you give like I think we have to experiment with Cloud Code, and I use Codex a lot, but not Cloud Code. I mean, we do use Cloud Code, but yeah.
Life is too short, like to experiment with different tools. Once I find something that's working, I use it until something else is clearly better. So I've been like 4 months on Cloud Code, and I'm not regretting it. And I love Google. I'm Google partner, but I'm still resisting to try their Gemini command line, because you get burned a couple times. I just have to deliver code. I cannot tolerate them getting better on me.
Yeah, but when you do that, I mean, you probably would review all of the code, right? Like, I mean,
Of course.
Yeah. I mean, do you divide?
It's not vibe coding.
You divide.
Okay. Oh,
yeah, I mean, you divide?
This is not coding. Nothing to do with vibe coding. That's why this company, Every.io, calls it compound engineering, because everything you do has specification. So we are using Kanban. That's a project board in GitHub issues. You define what you need to be doing. You define tickets. You have an AI to brainstorm with you. You define it, you validate it, then you do use test-driven development. Test-driven development means you first design failing tests. It's like paired programming in the old days.
Yes.
Then the system, and then you have AI code until the test is working. Then it validates the test. Then you do, validations. And then even if you use Cloud Code, they recently added 2 commands. One is flash review. It does peer review. When somebody asks you, please review my code, you just ask Cloud to do it for you. It finds amazing things. And then there is security review, because there is lots of security problems nowadays.
Yes, I mean, yeah, that's great. We do use, I do agree with TDD, because TDD helps in grounding the model output, so you don't have to write the code immediately, but we do use that a lot. Like, we do TDD, even when you're using Cloud Code or any of these AI tools, we first only go with TDD approach. We first write the test cases and then write the code to pass those test cases. That way, we're grounding the LLM to not go beyond and hallucinate some features that it's not. And also bugs is really, we previously did just, Cloud coding, like just asking Codex or Cloud to just do something. But, we did face a lot of bugs, but TDD definitely helped us a lot. So we do that as well. Yeah, so Sharad, I think we did fine-tuning using LoRa's we did like previously, but small language model, not the foundational LLMs. But I think foundational LLMs, you could still do it. Yeah, sounds great. Anyone has any more questions or anything to discuss about? Yeah, I think definitely we enjoyed a lot learning from you, Daniel. And if anyone has anything to discuss, anything you're building, please do share. Oh, this is the meetup. Okay.
Oh, I was on mute. Yeah, so you asked me for the meetup. So there is only one meetup planned, but it's probably going to pivot to the topic will stay the same, security with AI, but we are changing presenter probably. So, but look at the past events. And choose one topic that interests you and dive in, and DM me if you need guidance.
That's great. So how often you guys do the meetups?
We try to do 10 meetups a year. I thought we finished for the year, but we have somebody from Google in November talking about Gemini command line interface. It's time to feature them. And
okay, sounds great.
And then just talk to AI. And if you're not technical, if you're more business oriented, company HubSpot has their CTO is really, really smart. I forgot his name, Dharmesh. But Hugging Face AI, he first started Hugging Face, and now he has agents.ai software. The way he thinks is good. I never use his software, but the way how he maps AI into business is awesome. And then his other partner, Kiran, he's a marketing guy. Again, I'm not a marketer, but the way they come up with the prompt to help them with marketing is just amazing. So that's if you're more towards business side, not If you're thinking like it's like in the car metaphor, it's when you're planning where to drive the car. It's nothing to do about driving, nothing to do with under the hood work, but planning your destination. So these two guys are useful for non-technical folks here.
Yeah, absolutely. I mean, I do follow Dharmesh, HubSpot founder, the one who sold that. I don't know which domain was it. He sold a domain for like $11-12 million for
ChatGPT.
OpenAI.
ChatGPT sold it to
No,
OpenAI.
chat.com. I think it was
ChatGPT.
chat.com.
Something. Yeah.
Something. Yeah, he sold
He's
some
really
domain
smart.
to.
I love his metaphor.
Yes.
The recent conference, he had a metaphor. It was a movie metaphor. Two movies. Movie Her, which was AI, and the movie Iron Man. And I like AI not because what it is, like the guy in the movie Her, but I like AI because what it makes me to be. He feels like Tony Stark with Iron Man suit. And that's exactly the power you get to feel if you use Claude Code. And I don't work for them.
Yeah, definitely. I mean, yeah, you embraced AI, and I can definitely say that from your whatever you're saying, you use AI to write code, and so you were a developer before too, right? I mean, which language do you develop in?
Nowadays
Daniel?
Python. It used to be
Python.
It used to be C, C++, Java. I'm
Oh,
old.
and then okay, now you use Python, but yeah, but you already know OOP, so and you were a developer, so yeah, you just running with it. Like I know you how empowered you would feel with Cloud Code now, right? Because
yes. And if you're not a
understand.
developer, you have to learn to read programming languages. So you don't have to code it, but you have to be able to read.
Yes. I mean, I do. I mean, I was a dev. I mean, I can't say I was a dev. I mean, I used to do Python development in 2016, 2017. I developed a lot of multi-threaded, multi-processing, huge applications in telecom. And then I did DevOps and cloud and also cloud native applications, microservices. So these are all now when Claude writes code, I mean, when reviewing it, I can answer and I can question it. But I do the same thing with my interns, and I see their level of when it's doing something, the way I mean things that someone who has experience would see. I don't think someone who's just getting into software may not see that. They can ignore it. So that's the only difference which I see with cloud or any coding. If someone says, "Oh, you know what, I can just code everything," and because I have cloud code, but you don't have domain expertise because that's a domain. It's okay. Even if you can code now, anyone who say I have AI now, I can be a coder. I don't think that's right because
but they
if you
have to
don't
be
know
curious.
coding, you cannot.
They have to be like, so there is a Anthony Robbins used to say every master was once a disaster. So don't be ashamed if you don't know something today. When there is a will, there is a way. You're going to learn that. So learning programming languages is no longer like it used to be in the past. In the past, I would grab a book, sit for 7 days in the library, study it, and then try to code a little bit. Now it's like moving to the country where you don't speak the language. You get thrown into it and you just watch AI generating the language for you. And then you learn as you're questioning, understanding it. So that's how I picked up Neo4j Cipher language. Like maybe it's because similar to SQL, but I never seen that before. And suddenly by having AI write it and you review it, you become good at that. But that's pricey learning. So on a project, they asked me to develop Visual Studio Code plugin. I was never a TypeScript developer. So you do make these mistakes when you don't know when it's lying to you. But if you're curious, eventually you're going to develop taste and experience to judge it. So like now I know what I didn't know 6 months ago.
Yeah, I mean, this learning process is also expedited with AI because now previously when you want to learn something without AI, you had to Google through the documentations. Now you
to
learn the
library,
documentations.
read books, watch YouTube. So that's another problem. Like even if you're a workaholic, you don't get to have a break before. Like even laying down in a bed and reading the book was kind of relaxation. Now you get answers instantly. Like my days are 12-hour long. Like I had a quick meal and then jumped to your call.
Yes, that's nice. Yeah, it's a great talking to you, Dan. I mean, everyone who's in this call, like who are newbies and want to learn something, I think all the insights that Daniel shared, I think, yeah, definitely, we are living in an era where AI, if you partner with AI, learning anything, you could do that. I mean, I mean, I can say we are lucky to be living in this era where AI is being so smart that learning any domain, it should not take much time. Only thing is you have to be curious, ask right questions, and don't hesitate to fail, because now when you fail and ask the right question, you always have a teacher who can explain concepts to your level. So that never happened in history of humankind. So we are lucky to be living this. But yeah, I mean, we are right on time, but it was a great discussion. I think definitely enjoyed this conversations with all of you, and yeah, everyone have a great evening and a great night. I think we'll again have a second following meetup.
Thank you for teaching us vLLM.
No issues. Thanks a lot.
I did want to learn it, but I'll have to.
Sure, no problem. Thank you, Daniel.